Haha, I almost forgot. Um, okay, let's get started. Join Discord and then get Suki in here. Hello, hello.
Hello, hello.
How's it going?
Good. How's it going?
Pretty good. So I put the link for the Excalibur in like the text chat for the voice.
Yes, I got it. Same difficulty as always, but we'll get there.
Were you able to read much of chapter 5?
Yeah, I ended up getting through most of it.
Okay.
Some of the last section was a little fuzzy, but yeah.
Okay. Good to hear. I think last time we worked in chapter 5, Penlux and I got through problems 1 through 3. There were only like 9 or so total for that had like solutions, so and there were like 1 or 2 stars, so I was kind of going down the list.
Okay.
I guess I'll get number 4 in here.
Move picture. All right. Is that a fembox?
Yes, hello.
Hey,
Beautiful.
Penlux.
Oh,
How you guys doing?
Doing good? Oh, sorry.
I'm also doing well.
Awesome. And Finbox, let me know if you, or the Excel link is in like the text chat for the voice.
Oh, that's right. Yeah, thanks
Um,
for the reminder.
Yep, yep.
I don't know how useful I'm going to be in the Excalibur, but I'll just come along anyway.
It's nice to have the moral support. All right, so I think last time we ended on 3, so I dragged in 4. 4 says the divergence of E. Show the divergence of the E field given equation 5.15 is 0, except at the origin. Work with spherical coordinates. So I think we want these first 2 equations here for part A.
Yeah.
I guess they're just kind of plug and chug, isn't it?
Sure feels like it.
So, oh yeah, I was gonna mix up as E prime, but I don't think we have to care about that. It's equation 5.15.
So it depends on R and theta, but not phi, right?
Right.
That's
nice. Helpful.
The complicated term goes away.
Yep.
So our first partial is with respect to R. So we get minus 2q, and actually the 2 will cancel. So we get 2 pi epsilon naught r prime cubed, then 1 minus beta squared. Or 1 minus beta squared. Sine squared theta prime 3 over 2 r hat. I think that's good for the first vector. So we have a theta vector here too. Sorry, what?
Looks good to me.
Okay, good. Hey, Phobos. It's a little bit of an annoying derivative to take for theta. I guess we're gonna get a minus sign though. And we have a 1 over r factor in front. Oh, I deleted the wrong piece. Okay, so q over 4 pi epsilon naught r prime cubed. Hey, math channel. And then df d theta. Ugh. Okay, we're gonna have a minus 3 over 2. I already put the minus out front. So then times 3 over 2 1 minus beta squared. Oop, not in parentheses. Or at least parentheses like that, I guess.
Yeah.
It's beta squared.
Sine squared.
Beta. And then that's to the... Oh, 5 over 2. I was about to do 1/2. And then the chain rule. Oh, we're gonna have another minus sign. Okay, I'll just make that a plus.
See the plan. Okay, yeah.
2 beta squared sine theta. Wait, this beta... No, yeah, the beta squared should be there, right? I'm
Yeah.
forgetting my calculator.
Squared
Okay,
should be there, yeah.
then just a cosine theta. Or does that also have a beta squared? No, it doesn't.
Right.
So does this all turn into 0?
One can dream.
How are we going to get rid of that 3? Oh, is it a...
Is 0 except of the origin? Right. Hey, Brian. It is a lot of symbols. So each of these independently has to be 0 because they're different vectors. We can't like add them together for a cancellation.
So I'm gonna collect some terms. And then that's 1 plus 1
Hey, Thunder.
half, 3 halves. Oh wait, am I getting this wrong? This should be R.
Too many letters? Yeah, this
Oh,
there's very few numbers
wait
here.
a second. Okay, a little bit of happy news here.
Oh, okay.
We've got the wrong formula. We're doing gradient instead of divergence.
Oh,
that
Am I right? I think
is
that's a
true.
gradient form. Okay.
it should be
Because
del
I was
dot.
all of a sudden
Oh
like,
my
how is this
gosh.
going to be 0?
I pulled the wrong one. I remember being confused in the appendix which one I should choose, and I guess I chose wrong.
The only reason I realized this because I was like, wait a second, I think divergence is not supposed to have any vectors in it.
Vectors, yeah.
That does make yeah, that's a bit of an
Well.
oversight. My bad. uh curvilinear coordinates. I want del dot A, and I just did del F. Ugh.
Oh, yuck, this beast of a formula. Oh no, I'm looking at cross product. We don't need cross product.
Okay, del dot A is divergence, right? 'Cause the book just
Yeah.
says the words div or curl, and so I don't remember what the symbolic. Okay.
Yeah, but the dot is a D for divergence, and the cross is a C for curl.
Oh,
Right? The words both
funny.
start with D.
Yeah.
I guess so. Yeah. I mean,
Dot
there's literally like
divergence.
a cross product interpretation, though, isn't there? And like a dot product interpretation, or like you
Right,
dot it
yeah.
with the partials. Okay, so del dot E. Oops. Yeah, folks, I'm also glad they give us the formulas. I'm just not glad that I can't choose the right one. So the first part of this formula, we have 1 over R times, and we have to do the partial after multiplying in an R.
Right.
Can I do this with mental math to avoid too much writing? So it's basically the same thing, but we have just an R to the power of 1. And we're taking the derivative, so we have a minus sign in front. 4 pi epsilon naught, and then go back to r prime squared. 1 minus beta squared. 1 minus beta squared. Sine squared beta prime. 2 like that. We don't have to worry about the z term. And we derive with respect to theta. Q over 4 pi epsilon naught r prime cubed.
Did I just hear the word derive?
Yeah.
I thought I heard that.
Wait,
Oh, I didn't have to throw away this work. Not all, but for this one. What's Doogie?
what is... So there's no theta direction, right? This field.
Oh, this is the magnitude in formula 5.15.
Right.
Yeah.
And it is a...
Okay. Good catch. So, well, does that mean that our first term is only 0 then?
Yeah, that's concerning.
Yeah. I want to find this 5.15 equation in context. Because I wonder if they did a sub where theta used to be r or z. It did used to be z. Well, They did it with Cartesian. So they had x's and z's and they converted it to polar.
Sure. Makes sense.
Just field E. So would we have to like somehow decompose this? I don't know how you decompose into spherical coordinates.
Isn't this magnitude just in the radial direction?
Oh, that's true. This is again, this is a what, Cartesian? Not Cartesian. It's the other one, cylindrical. Do we have a true spherical formula in the appendix?
It's entirely possible I grabbed the wrong one a second time. Oh my god. I did. Okay, third time's the charm. I just saw an R in the formula. It's like, oh, that has to be it.
All right, everybody keep an eye on Don when he goes to Appendix F.
Yeah. Okay, yeah, I'll show it. Spherical.
Okay,
Delta
the good
A.
news is that this is very easy. Actually.
Okay. Oh, right. Okay. Because the R's go away entirely.
Yeah. Derivative of a constant.
Ugh. I don't know how much we need to actually write of this because now it's just obvious. But r prime squared equals 0. Okay. Natural divergence of V is zero based in Cartesian coordinates in the form of V given equation 5.13. Careful, there's something missing. Okay.
That's
Oh. So we got the z, but the x they gave us is really like square root of x squared plus y squared, isn't it? I think that's what we got to deal with. Because I think they're treating the distance along the xy plane from the origin as I think they're calling that x in that picture.
Right. This is just the xz plane.
Right.
So x is really r, and now we do actually want cylindrical.
Well, they say to do it in Cartesian though, right?
Yeah, that sucks. Okay. I guess it's inside of a square. It's fine.
Hey, Critical, it's the reading group we're doing every Saturday.
Can't we use those same two equations but just change the x prime to square root of x prime squared plus y prime squared? I mean, it's messy, but those two equations in 513, I think we can still use them.
So which part of it do you want to change?
I want to change every time we see the letter x prime. Well, first of all, I don't want to use all these primes because I don't like them, but I want to I want to change every x to square root of x squared plus y squared. Because isn't that what we have to do? I mean, if we, does that seem right, or is that not? Is it not that easy?
I hope it's something that's that easy. I'm trying to remember where this comes from, because like I wonder if the y gets the Lorentz contraction or not. Maybe it doesn't matter because it should be, we expect it to get 0 anyway.
Oh yeah, I see what you're saying. Yeah. So how did they set this up with just x and z? I forget.
So x is running parallel to the velocity. Oh,
right.
That's interesting.
Oh.
So y
okay.
does not get contracted.
Oh.
Can we just say it's the
Wait.
same thing?
Oh yeah, y does not get contracted.
So there should be some symmetry where like y is basically the same thing as z.
Yeah, yeah.
So if yeah, we could probably modify the distance in the denominator for each of these just to include a y squared term. And then yeah, I like this at Suki's writing.
Right, and then take. Oh wait.
Ooh, I think all the denominators should be like, they should have an x, y, and a z in all three equations. Other than that, I think I agree with this. Or wait, do we want the gamma though?
So I want to replace both
Oh,
z
there should be a
prime and
gamma. If z has a gamma, then y should have a gamma, I guess.
right.
Okay.
This is what Fembox was saying is make this substitution. Because they're both radial.
Does that? Oh, and that gives us what we want. Okay. Yeah. I said it definitely gives what we want in the or at least what I want in the denominator. Um, but what am I trying to say? So like we do need to modify these first two equations to include a y, and that substitution would do that. If we like, pulled out those z prime squareds and put in this.
Why do we have to change the z? I didn't follow that part.
Well,
Um,
oh, go on.
So Z, based the way they're setting up the problem, like you were saying, FemFox, is that Z is R, right, in cylindrical coordinates. We've chosen the xz plane, but we could have chosen the xy plane or any other plane as long as it contains the x-axis. Um, so, um, so we need to do two things to sort of unwind that assumption. First of all, we need to replace the Z with an R. Um, which here,
I thought in cylindrical, r was like r squared was x squared plus y squared, and z just stayed z. Isn't that what they were doing?
you be one coordinate that you keep the same and two that you turn polar.
Yeah.
And we want to keep the x the same because that's special for this problem, right? It's the direction of motion.
Okay.
I'm imagining more like they took a level curve of this three-dimensional thing with y always equal to 0. Uh, I think your interpretation could be the same, Sticky, but I guess I'm kind of thinking they just always let y equal 0 so they can get a two-dimensional graph, but I feel like it should be as simple as just saying like, hey, we need a plus y prime squared there, in there, because they implicitly let that be 0.
Yeah, that I'm satisfied with that.
Okay.
Right, as long as we have that third component in there. Right, and from your interpretation, that is the third component disappeared because the numerator was 0, right?
So I would say we take those two equations and make them into gamma x prime squared plus y prime squared plus z prime squared to the 3/2. And then, or this should be the denominator for, I guess, all three of them, is what I'm saying.
Right. Yeah.
And then I otherwise agree with this equation here for y, because it should be basically the same thing as z.
Yeah.
Okay. Oh, these derivatives are going to be a pain to take. I guess they'll come out looking pretty similar. Oh wait, it's a quotient rule for CX. Oh no, these are all quotient rules?
Yeah.
Wolfram alpha. Save me. X over. I mean, I guess we could treat it as like root x squared plus 1, which isn't so bad. I should have told Wolfram to actually take the derivative of that. Really? That's weirdly clean. It's just 1 plus x squared, or 1 over x squared plus 1 to the 3 over 2. I guess so. Wait. I typed it in wrong. That's why it looks weird.
Is the gamma supposed to go on the X, or is the gamma supposed to not go on the X and instead go on the Y and the Z?
It goes on all three,
Okay.
showing up differently. It shows up in the Y and the Z because of the field dilation. Those are
Yeah.
both perpendicular to the direction of motion, and then it shows up in the X because of length contraction. The X prime coordinate is smaller than the X coordinate, so.
Ooh, this has a gamma. Can I solve JE advanced questions in the next stream? Probably not. I have not had good luck solving those. X prime squared plus y prime squared plus z prime, oops, squared to the 5 over 2.
Okay, I have another question. If we have a point charge, we're dealing with a point charge, right? So do we have to worry about the length being contracted if it's just a point? So okay, so if I understand what you told me a minute ago, in the Y and Z directions, we're thinking about the field being stretched or compressed, right? And in
Right.
the X direction, we're thinking of like an object, a charged object being stretched or compressed.
The coordinates are what's being
Right, the coordinates.
compressed.
Okay, so it doesn't matter that it's a point charge because it's the whole coordinates.
Right.
Okay.
I guess we'll do derivative with respect to y here. I'm not very convinced this will be 0. Oh, it might be. Oh, I think I can see how it's going to work out. The denominators will all be the same.
Right.
Okay.
Then how does the magic happen?
Does this y does not have a gamma here. This x up here does, though. Okay, and then the one for z should be nearly the same. Except, ooh, you need 2y prime squared. Okay, and hopefully this works out. Um,
2z squared.
so we have a gamma y prime squared. S2 gamma. Oops.
I don't think the Z's are working. Do we need a 2 on one of the Z's?
Oh, we do.
Well, whatever wizardry you just did, it looks like it's working.
S2. Yeah, I think it is. Gamma. Yeah. Okay. This looks like it's zeroed to me. And critical. It's like I said. It's if I have time, I'll try it. And Cypher over YouTube. Why are you spamming dots? Okay. I guess that's how we do it for 5.4. So it's except at the origin, which is where the point is, and it's not defined at the origin, the things that we did
Right.
anyway. So I wonder if there's like something more that we can say about it, but like I guess we just did it right.
Yeah, it looks good.
All right, start grabbing number 5. Oops. Okay, E from a line of moving charges. An essentially continuous stream of point charges moves with speed v along the x-axis. The stream extends from -infinity to +infinity. Let the charge density per unit length be lambda, as measured in the lab frame. We know from using a cylindrical Gaussian surface that the electric field at distance r from the x-axis is lambda over 2 pi epsilon naught r, just our normal formula. Derive this result again by using equation 5.15 and integrating over all of the moving charges. We'll want to use a computer or the integral table in Appendix K.
Hmm.
Okay.
And so this is, and so this field that this is the same equation that we used in the last one. I think so this is for a single point charge, and the thing we're going to be integrating is over all point charges, I guess.
Yeah.
So this is going to be like, we need to figure out what dq is, I guess. With respect to like r
Alright.
and theta. I don't know how to work that out though. I don't know like what to do with this. Oh,
Well, we don't need DQ, do we? Don't we just take that given electric field and break it into like parallel and perpendicular components?
I think that
I'm
was
just
done
throwing
for
that. I'm
us to
throwing
get
that
the
out there.
result of
That
the
might be
formula.
wrong. Yeah. Okay. Okay. Yes. Because I'm thinking of using 515, but I can't do that, can I? Because they want us to derive 515. All right.
No, we use 515. Derive using 515.
Oh yeah, no. Yeah, we're trying to derive E equals lambda over 2 pi epsilon naught r. Well, yeah, couldn't we just take E prime in 515 and break it into components in the direction of the velocity and the direction of the point charge motion and at right angles to the motion?
Yes.
And then if we could do that, couldn't we integrate those two things?
Yeah. There should only be like, yeah.
Yeah, Q. Yeah, okay. An essentially continuous stream of point charges. Yeah, sorry, Don. I think I derailed your idea. I think you were probably on the right track there. It does tell us charge density per unit length is lambda, right? So
I don't know where to go with this though. With this little like DL length of thing. Well, I guess L could be X, which maybe helps a lot because they're going along the x-axis.
Okay, I want to be careful though. We're computing. This x is not the same x as the one that shows up in the theta.
Oh, as
Right.
measured in the lab frame. So we
Well, but
could.
it's not even the same x. Like, because the r prime theta prime is talking about an arbitrary point in space. And the x that we're using here is talking about the location of the charge. So this is not
Oh,
like a transformation. It's just a different variable.
okay, yeah.
I am in support of using little l.
Okay, critical. Um, hmm. Oh, wait, is this E prime of L? Shouldn't be E prime of XYZ?
Yeah, what do I mean there? I mean it's the e prime that
Like, or whatever the
the
contribution from
force.
L?
Yeah.
Okay.
That's probably prime all of those.
Propose, I thought I missed that. So I'm glad I didn't just like forget about it, but hopefully you're able to do it soon. Hey, syntax. Some applied math. I mean, around here, you should be proud of doing applied math at least.
So when we derived this formula originally in chapter 1, right, the electric field at a distance from a infinite line of charge, we were considering them to be stationary. Now, when we did that, I know we used Gauss's law, right? Because that was the easy way to do it. Did we ever do like an infinite integral along an infinite line of charge to calculate it that way? I don't remember.
Hmm.
Might have been done in the book.
Maybe.
This seems
I feel like
Coulomb
sometimes they did things the hard way, and then they did
Um,
Gauss's law to show how much better it was.
I found it. I mean, isn't this function like because Gauss's law still holds for moving charges? We expect it to be the same. We're trying to show that why it's the same.
Oh, you found it. 112. They did do it. There it
Yeah,
is.
page
Nice.
28. Yeah, I remember there's some weird geometry happening in this one. You can extend those ketchup holding
Okay, I
pins.
got another question for you guys. It's related to this question. It's because I haven't I'm going to be honest with you again, I haven't quite finished this chapter. I read some stuff on relativity this week, and I was trying to wrap my head around special relativity a little bit more, but I didn't quite get to the end of this chapter. But anyway, here's a question. So if you have this infinite line of point charges that are moving, right, with a current in the x direction, and we want to find the electric field at a point off of that line, can we turn it around and assume that the line of charge is fixed, and then consider the point where we're trying to find the field as moving in the opposite direction with speed v? Is that legit, or does it not work that way?
I think that's what E prime is. So I think that's legit.
Because I think I remember at the start of the chapter, it said we are going to have 4 cases. We're going to have two fixed charges, and then we were going to have a fixed charge, and a moving reference, and then we were going to end up with both things moving, right? Like 2 charges that were both moving. And then, but the 2 middle cases were where you like either your charge was fixed and you were moving, and you were trying to see how the field looked from your frame that was moving, or you had your frame was fixed and there was a charge that was moving, right? And I kind of felt like those 2 things should have been the same problem, just looked at from flipping the coin over. But I'm not sure if that's true or not. I feel like Dr. Cook said something last week that made me question it, that if you could treat those 2 things as basically the same problem. I don't know if it helps us with this question anyway, but it was a thought, because I thought, well, instead of all these charges moving, we could have the charges fixed, and we could just consider our point to be moving the other way.
Yeah. My feeling when I was reading the book was that the sections were kind of talking past each other, and maybe this is what was going on there.
I think it's going to have to be something like what you're saying, though, Femlux, because the lambda that we measure in the lab frame is when the charge is moving and the point is stationary. But I think this E prime thing comes from the point moving and the charge being stationary. And I guess I see what you're saying now with like, why can't we just break it into components and translate it back? But I guess this is for a single point charge, which is why we still need an integral of some kind.
Yeah.
Um,
Okay, I remember what's going on here. Yeah, short answer, yes. The difference between the two sections is that we're interested in the force that appears in two different places. Um, yeah, and this is what I meant by they're talking past each other, because the 5.6 doesn't say anything about forces explicitly. It's all field calculations. Um, but 5.8 is asking about the force. I mean, both things are experiencing a force, right? Whether it's moving or not.
yeah.
And so the question is like, I mean, but the symmetry or the asymmetry here is like picks which one are you measuring the force at? Are you measuring the force at the thing that's moving, or are you measuring the force at the thing that's not moving? I think that's the point.
Hmm. So I assume we need to do something like what Stugi has drawn here. We need to, I guess, get everything in terms of R or in terms of theta. Um, just do like a second drawing just so I don't mess up the first one. Like we want a right triangle, something like this. Now that's like theta. Looks like 0. And that's theta plus d theta. R R plus dr. Hmm. Now because we're getting back into the weird geometry of getting this thing with Coulomb's law. But we could say something like dl, oh, that's a terrible, is equal to r plus dr minus r equals dr. I'm also ignoring everything about relativity right now. I'm not even thinking about it.
Yeah.
Um, in this vertical distance is some fixed distance that we could call like y or something. So we can do trig. Sine theta. Well, I guess I'm doing tangent if I'm naming that as y. Tangent theta is equal to.
Actually, that y is where we really want the r. But it's a
Is
little
it?
bit late
Oh,
to change
yeah.
it now, I guess.
No, that's right.
Oh wait, why did I put r like there? R should be the hypotenuse. I'm defining this all wrong.
Yeah, I wrote R as the hypotenuse, but I think Fembox is right. It's supposed to be the vertical.
Is it
Um,
really?
Well, just because that's the definition of where we're trying to define the field, or where we're trying to measure the field, right? It's a orthogonal distance from the line of charge.
Oh. Am I getting my r's confused?
I'm getting my R's confused.
I always thought of that as r for like radius, you know, because it's like a circle around the wire or whatever.
Prime.
Shouldn't be the distance from the dq charge that we're interested in, not just the closest distance.
Well, yeah, there's two different r's,
Oh,
I guess.
yeah.
So there's two different r's, right?
This is for a point charge, the formula that we're working with. Not it. We do not have lambda over 2 pi epsilon naught r. So like I guess in going back to the original problem, like the formula for an infinite line of charge, that r is definitely the orthogonal distance. But in
Yeah.
equation
You know what?
5.15, it's a point charge.
Yeah, I think forget I said it, right? We'll just fix it at the end. I think it's better. Worry about it at the end.
Okay. I mean, I still want to make r the hypotenuse. I think that just makes sense.
I'm in
to
favor
me.
of that now.
Okay.
Hello. If you didn't do that though. There we go.
And I guess we have a trig problem now. How should we call the bottom? Or I guess it's the top. So I want the length of this little bit of charge. That's what I'm trying to do with all this trig. I don't want to call it x. I should call it something random like a, I guess. Because I just don't want to get confused with x later on.
Yeah.
Or is x okay here? Maybe x is okay. I feel like it is. So what I want, dl is equal to, I guess I'm saying dl is equal to dx. If I do call it x. And then I guess we want cosine theta is equal to x over r. Actually, this is easier to see if we do. Ugh. X plus dx minus x. So then cosine theta plus d theta is equal to x plus dx over r plus dr. So if I'm not being too unhinged right now, I think we have r plus dr cosine theta plus d theta minus r cosine theta is equal to dl, and we want to get rid of the r's or thetas somehow. And maybe we're going to want sine to do that. So if I call the
'Cause it's a
orthogonal distance
constant.
y, yeah, then theta is y over r. I kind of hate when we have r plus dr and theta plus d theta, but can do it. I guess I'm getting rid of r's with, because I don't want to deal with arc signs or anything like that. And dr must be, ugh, it's an annoying derivative. Minus y over, well, that's just or that's cosecant? I don't know the derivative of cosecant.
Well, that would just be cosine, right?
Is this what I have okay?
I think so.
Good.
Isn't the derivative of cosecant? I feel like there shouldn't be a cosine. Cosecant, I'm saying it's cosecant squared times cosine? Minus cosecant cotangent. Oh, right, because cosine over sine. Okay, yeah. Yeah, we still have a d theta that's trapped inside the parentheses here. I don't know.
Oh, that's right.
Can we do a sum identity and then say that cosine of d theta is about 1?
Right. Or
So maybe we'll do that sum identity first. I don't know if that's actually valid, but... Oh god, I know it might... Try that, he's handy. I feel like they didn't do this when they were doing the Coulomb's law thing, though. Like, why didn't they have to deal with the cosine of theta plus d theta?
point in the y direction. A.
Hmm.
equal to...
It's getting complicated. So I guess what I would say is that cosine of d theta is about 1, and that sine of d theta is about 0. Oh, well, that gives us a really simple thing, though, if this is true, which is a big if, because the arc cosine thetas go away.
Sine of d theta is not about 0. It's
Oh.
it's about d theta.
Oh. Fair. I was just kind of thinking about where they, like, close to 0. So, maybe we shouldn't... Isn't there a swelling approximation for cosine? Or we should be able to get one, right? Shouldn't be pi over 2 minus
It
x?
It is 1, because the Taylor expansion is like 1 minus x squared, right? And so that would be a d theta squared. And
Oh.
we kill squared
Okay.
differentials.
Well, it's convenient, so I'll definitely believe it. Flex, thank you for the follow. Okay, I feel like I want to go vertically now. Ugh. I feel like this is not the right path, but I don't know what else to do if not all this crazy trig stuff. R plus dr cosine theta minus sine theta d theta minus r cosine theta. So the r cosine theta is at least go away. That's what I saw initially. But all these other terms I did not see. I'm not a fan. But this is something workable that we could sub out the r's for. Oh, and r is y over sine theta. So this first term just becomes minus y d theta.
Right.
Okay, that gives me a little bit of hope. Dr becomes minus y over sine squared theta times cosine squared theta d theta. And then dr d theta sine theta.
Well, that dies.
It does?
Dr d theta, too many differentials.
Oh, you know what?
Square
Okay.
differentials die.
I won't question it. Hey, Cook. We're working on a problem 5.5, but it's kind of gone to a... I feel like it's going to hell or doing something too complicated, but I feel like this should get us the right answer if we set this up right. We probably need to think about relativity too.
Well, this is all in the primed frame.
Okay. Hey, Dillip.
Dang it. Good. Little dx, which is what we called little dl. R, which is what we called y divided by cosine squared theta. Interesting. the same as r theta.
Is this line to be continued, or are you saying, or is that like the end of the line there?
Nope, that's it. If you want the rest.
Oh, okay. Oh, you're factoring that out. Okay. Oh. I see. Okay, that's nifty. Oh, so I guess the... Oh, wait. Okay, so this is, like, pretty clean. That integral... Oh, wait, that's kind of a clean integral. Isn't that cotangent? Yeah, it is just cotangent. Why do we... Maybe they're saying we can use a table for that? The integral table in Appendix K. Do they give us this integral?
Still have a...
Oh, the rest
No,
of the
it's
stuff.
worse than that. Yeah.
Okay.
It's the correction factor.
Yeah, well, we're doing all this because... Okay, this is our DQ. Right, we still have... Okay. Oh, interesting, Cook. I can take a look at it after this. I assume there's a trig thing you can do in there. So... Okay, all of this is equal to DL, and we're seeing that DQ is lambda times DL. This DQ and lambda are in the lab frame, not in the primed frame. Well, I guess the L, we were doing it implicitly in the primed frame, and we should have been more specific about that.
But yeah. I mean, I guess both things are true, right? DQ is DQ. But then we can choose whether this is the primed lambda and L or the unprimed lambda or L.
And shouldn't lambda increase by a factor of gamma and L decrease by a factor of gamma? Is there something weird like that happening where it's just going to end up being the same anyway? Because the gammas cancel?
Right. Yeah, and I don't remember which way it goes, but...
I guess we could say that lambda is equal to Q over L, but lambda prime, oh, well, maybe not. It's equal to Q over, the length should be shorter, so 1 over gamma L. Maybe we have to say that.
Right.
Roland Martino, thank you for the follow. L prime. No, just that. But we'd say 1 over gamma L is equal to L prime.
Right, and so I want to take this to be lambda prime, or excuse me, no prime, lambda.
Okay. See, I think we could do that then. And the gammas cancel. Oh, who cares about Excalitral's complaints? So what we would do here now is we have the L with respect to theta, and we would want to integrate from, say, minus pi over 2 to pi over 2. Including all the original, like 1 minus beta squared over like 1 minus beta squared sine squared ugliness.
Right.
Do we need to worry about the relativity? Like, should we break it out into parallel and perpendicular now? Or later? I don't know if that matters.
So everything that we just did not care about frame, except for this last little bit. Uh, is that true? Yeah, that's true. But in any case, we know everything in terms of the primed variables, so I would rather integrate with the prime variables.
Okay.
Deal with the fallout later.
So let's cross our fingers. I guess I'm going over to the left and working down below. Or after that start, I was going to write my E backwards. So what, dE prime is going to be equal to... I mean, I shouldn't write out that much detail. It's going to... E prime is going to be equal to minus pi over 2 to pi over 2. So Q is going to be the thing that I'm just going to put a 1 there for the Q, or we'll put the Q off to the right. 1 over 4 pi epsilon naught can come out front. 1 minus beta squared can come out front.
Right.
So we have 1 over r prime squared, which actually we know as to be y over sine theta. So we get sine squared theta over y squared. Yes. I guess I should maybe put the q in front, because that just makes more sense to me. So it's minus y over sine squared. Oh, really? Okay. I'll label these in a second. Times, okay, so, oops. I'm saying this first bit is dq. The second bit is 1 over r squared. And then the third bit is just the 1 minus beta squared. That doesn't need to change. These are primes. And y is the same in both frames.
Agreed.
Beta squared, sine squared, theta prime, 3 over 2. And I think that's our integral.
I think so.
So it's really just 1 over beta squared sine squared to the 3 over 2 that we're integrating here. And of course we have this exact one. Hey, thank you, appendix K. Oh wait, there's a cosine in the numerator there. Never mind. That's a much easier integral with the cosine in the numerator. Really? Should we have a cosine or something up there? They said that you could use appendix K. But we don't have it with a 1 in the numerator. The only one that gives there should be a sign X in the numerator if we use the one in appendix K.
Right.
Um, did I mess up a sub? Hmm.
Yeah, so I guess looking at the 112 before the relativity stuff, we were expecting to get a sign in the numerator, expecting one of those to not cancel.
We were looking for another sign.
Yeah, be nice if you can find one for us.
Okay,
If you have any laying around.
I'll keep my eye out. Yeah. Yeah, I kind of got lost in all the calculation of the dq in terms of d theta, honestly.
I was kind of making up as I go along, hoping for something simple. And it looks simple at least.
Does.
Trainer per cell uses confusion. It's super effective. So DR. I don't see it unless we're supposed to break it up into vector components, like a sine theta and a cosine theta.
Yeah, exactly what you're supposed to do. Because we know the EX is going to cancel. E prime X is going to cancel. So we want to integrate E prime Y. There it is. Good call.
Wait, we know what's going to cancel?
The E prime X. And the E prime in the X direction. Because that's, you got the symmetry.
Like that's going to be the same in both frames?
Well, in both frames,
Or
yeah, you still have the same chart, the same DQ. And it goes infinitely in both directions, so you're still gonna have that.
yeah, the X's are okay. I it's not about the frames, right? It's about for every little DL charge, there's one on the opposite side of it that cancels the X. So we only expect a vector in the Y direction, as I called it, or the Z direction. Sorry that I cut you off.
No, it's good.
Okay.
That is the Y direction.
Yeah, the X's should cancel. Like, we only expect something in the Y direction, or... I shouldn't say. What am I even writing with that? Y components. Okay.
All right.
And the integral table says you get minus, oh god. Yeah.
Yeah, I'm a little bit on the old side for Pokemon. I think my little even my youngest brother, honestly, I don't think he was into Pokemon.
I assume they may have to use like a 20 something. So we get a minus cosine theta prime meal maker sub xyz. One over 1 minus beta squared root 1 minus beta squared sine squared. Okay, if I haven't made another flub on copying formulas. I think we get this.
I'll take it.
Okay. So we can bring the minus sign out front. Cancel it. Not y. So cosine of pi over 2 is positive 1.
Right.
1 minus beta
Root
squared.
thing is just 0, or excuse me, it's just 1. So we get
Right, yeah. So that's the first term already done. Oh, wait. I'm doing something bad. Oh,
one of
because
those
sine
should
is
be
root 2?
negative. No,
Wait.
no, one of the cosines should be -1.
Ooh, for pi over 2? Wait,
Well, okay. In that case, it should be 0, but
what am I doing here? Yeah. I said the first one is 1. That's just not true, is it? That's not good. This is just coming out to be 0.
well, okay. Theta. Oh yeah, theta doesn't go from pi over 2 minus pi over 2. It's at negative infinity, theta is 0, and at positive infinity, theta is pi.
Oh. I think that was me finally copying whatever setup they did in chapter 1.
Two over 4, that's a half. We wanted 1/2, didn't we? And the 1 minus beta squareds are going to cancel. I think you guys got it.
Some magic happened.
We're just getting minus 2, right?
Because that y now turns into the r we're looking for.
Minus...
Right.
We dropped a lambda. I dropped a lambda because of the DQ sub.
Okay.
We just slam a lambda in front. Not question it. Oh, lambda prime.
Lambda prime, yeah.
Nobody question it.
Yep.
So let's see. Why do we have a negative answer?
Why
this
did I put
go
a negative
from-
sign there? That's a good question.
Yeah.
Oh, I dropped the negative. There was already a negative in front. Wait, there's a negative in front. I canceled it with that negative. Cosine of pi is -1. Cosine of 0 is +1. Headwind, thank you for the follow.
All right, let's just integrate from pi to 0 then. There, we got it.
Yeah, I mean, I think the sign is okay. Like, I don't mind editing the sign after. Shouldn't we have a gamma in here though, or something? I guess it's lambda prime. The gamma's built in. Like, I'd like to get back to the exact same form with just a lambda. So there should be a gamma here. You want to translate it back?
That, yeah.
Well, oh wait, I guess maybe E parallel. Is that gamma times or 1 over gamma? Or perpendicular? Wait, no. Yeah, the perpendicular should increase by a factor of gamma. I'm not looking in the right chapter.
Oh, I see, because the...
Yeah.
Yeah, okay, so field dilation means that...
Gamma. Oh, wait, no. Gamma E prime equals E. Because in the prime frame, it should be stronger.
Prime frame. The yeah. Yeah.
And then gamma times lambda prime. Oh no, that's the wrong direction. That should be 1 over gamma times lambda prime.
That's a Y, I see.
Oh yeah. They look pretty similar.
Field dilation means that if the charge, no, if the charge creating the field is moving, then the field is larger.
Yeah, I think so.
Okay. So that means that E prime should be larger than E.
Yeah.
Okay.
So 1 over gamma. Yeah.
And that would bring us all the way home, except for that minus sign that I'm just kind of ignoring. Okay. I kind of want to check the answer to this one and see how they did it in 2 lines. Unless anyone has anything that they'd like want to add on to this. Let's see, this is 5.5. So I'm sure there's a quicker way. Or maybe not. This looks a little... There's stuff happening here. What do they get for DQ? DQ is lambda RD theta over cosine squared theta.
It's about the same.
It looks like what they did in chapter 1.
Yeah, I'll look at their figure after this, but...
Yeah, same cube.
Oh, they get cosine. Oh, and then they do pi over 2 there. Okay. I assume this we could have flipped our balance. Or maybe I did something a little bit wrong with the trig and getting...
No, so for some reason, Purcell just decides not to use the same formula for E prime. You know, change the angle up on you. See that sine theta has turned into a cosine theta.
Cosine theta. And he just never uses sine theta, does he?
No, but if you compare the formula in the integral to the formula 515,
Oh,
Oh, yeah.
515 uses sine, which is
How about
why we ended up with sine. Because we made our choices consistent with that.
that? Okay. uh, okay, I don't know what's happening in the figure, but we did it right. That's the thing that I care about the more. So I think we did. I guess we got time for one more, I think. As long as it's not as long as that one. There was one in particular that I was interested in doing. It doesn't have a solution for it, but I'm gonna come to the bottom here and bring it in. Number 18. I just like this like figure, and I wanted
oh,
to.
this crazy thing.
Yeah. It's only 1 star though,
Okay.
so we have a non-uniformly moving electron. In figure 5.28, you see an electron. Let me make it a little bit bigger. In figure 5.28, you see an electron at time t equals 0 and the associated electric field at that instant. Distances in centimeters are given in the diagram.
Describe what the hell has been going on.
Yeah.
Okay, well, this looks suspiciously like a figure in section 5.7, which I haven't read yet. So
Oh, okay.
I don't know what's going on.
Oh no.
Something's been starting and stopping. That's my guess.
Yeah.
Hey, headwound. Yeah, exactly. I really enjoy this like group solving. I can talk more about it in maybe like half an hour or something, but there's a little cool Twitch math community. And we'll be able to call your Ian Stuckey streams as well.
Hello.
Yeah. Describe what has been going on. Make a description as complete and quantitative as you can. So I think the charge is moving to the... It either has... Well, it's at t equals 0. I assume it just stopped moving to the left. Which goes based off the direction of these field lines. Or which way they're curving, or changing.
Right.
It looks more like figure 519.
Oh, wait. So maybe it was moving to the right and then it stopped?
To the left, but yeah.
Oh,
Oh wait, sorry, no. Our figure. All right.
wait, yeah, we need to see where they... Okay, yeah, so this inner field looks like a static charge. So it just must have stopped because the things that are close are like a static charge.
Right.
Whereas the things that are far are like a moving charge.
Oh, I see. We have all these little radial lines that are pointing at 2 different points. Oh, that's cool. Is that what's happening? So yeah, they're all pointing at 12 centimeters, and then it moves and they're all pointing at 0.
Exactly. The field can only update at the speed of light. So if it only just started or stopped, you get this sudden transition. So all the field lines out here think the charge is still moving because it hasn't been updated yet.
Oh, beautiful.
And they do want a quantitative
What does that
description.
mean? It moved from... Does that mean it started at 12 centimeters and moved to 0?
I think we would guess it decelerated, like it was maybe moving at a constant velocity, from beyond 12, and then it started decelerating, I assume uniformly, between 12 and 0.
But what's the significance of 12 centimeters? That tells us like how much time there's been between when we looked at it and when it stopped moving?
Right. Things far away still think that it's at 12 cm.
Hmm.
Oh, wait. No, but that's...
Wait, so this field makes me think that the it's an electron. These fields are going inside, like, or towards. Are we raising an electron? They're also using an electron here in the figures. Okay. Since the field lines kind of bunch up on the right side here, it should have been moving towards the right. So how did it suddenly end up at the origin? Maybe it was moving
No.
to the right and it turned around? No?
No, it's been moving toward the origin. But things far away just haven't noticed this yet, right? So it stopped a while ago, is the point. Like if we pretend that this circle is at like 15, then the difference between things that know it's at the origin and things that don't are like 5 seconds away, or 5 nanoseconds
5
away,
times 10 to the minus 10.
whatever. Yeah.
It probably they're asking about a negative time? Oh,
Right.
jeez. Okay, so that was before. Okay.
Right.
Before it stopped, or... Oh, we are at t equals 0. Okay. In this instant. Um...
Hmm. Yeah, I don't get it. It seems like it would have had to teleport from 12 centimeters to 0 centimeters. Sort of like everything inside that circular part thinks it's at 0 centimeters, and everything outside that circular part thinks it's at 12 centimeters. So how did it get from 12 to 0? Does it just move so quickly that it can get from there to there basically instantly? So is it the time during which it moved is the time that the field lines did the sort of curvy arc parts? Is that what it is?
Yeah. When it's moving, the field lines kind of bunch up, I think, ahead of where the motion is. But I might be about the other way around, so I'm trying to figure out right now.
They bunch up perpendicular. Weird.
Yeah, it should be perpendicular, you're right. So it could be moving to the left because if we ignored the whole stopping thing, 0 and 12, back when the particle was at 12, and if it never decelerated, those few lines should be bunched up more perpendicular. So maybe it's okay that I guess I was getting mixed up with we only have some of the field lines here, and these ones off to the side seemed they were going the wrong way, but maybe it's okay. I think our velocity can be going to the left. Is that what you're thinking too, Stuki?
I think so, yeah.
Okay. You know, we should be able to make some kind of oops. We should be able to figure out how much time it decelerated over based off how big this circle is, like you were talking about.
Yeah.
And so, yeah, we were calling it 15 radius, or yeah.
Out.
Hmm. Managed to travel 15 centimeters. And the speed of light is 3 times 10 to the 10. Hey, Creative Association. I don't know what that means.
Привет. It means
Oh.
hello, I think.
Oh, okay. Hello to you.
So why 6 centimeters? 6 centimeters because 2 seconds. 2 units time.
So I think oh, that is 5 times 10. Okay, so you already way ahead of me there, Stuki. This thing happened in 5 times 10 to the negative 10 seconds.
That's when something changed.
That's a total time interval over which it decelerated, I think.
Well, that's the time for which the field understands the point has been at the origin.
Okay. No, yeah, that's fair. So it's been at the origin for that long. Or, yeah. Hmm. Oh, and they tactically, in part B, they give us minus 7.5. So it's like a time period and a half before what we got. So let's just write down some of the basic stuff that we've been saying. Is only 1L in traveling?
I guess.
I got the red squiggle of being yelled at, so. I know with modeling, you can spell it with 1L or 2Ls. We're having that issue when I was writing math things. I don't know if traveling is the same. Let's get to the left. It's A2 x equals, we're saying it only started decelerating at 12 centimeters. Accelerated. X equals 12 cm to x equals 0 cm. And stayed at rest for 5 times 10 to the minus 10 seconds.
Trying to think about what that 12 is telling us.
Yeah, exactly. I'm looking at figure 519 in the textbook and I'm trying to work out what's the significance of the arrows outside the circle.
Oh, Don, I think I talked you out of it.
Oh,
I think you're right. I think it was moving to the right and then stopped at 0. And so here's
oh! I might see it because the field outside thinks it kept on moving in the meantime.
right.
Oh. Yeah.
Also, my browser is just refusing to display the font. It's just like
Oh,
Times New Roman for you.
okay. To be honest, the default font in this thing is kind of weird, so I prefer that. It's a Excalibur head wound. Okay. Oh, I even wrote minus infinity when I didn't have before, but now it actually works. So I don't know if we want to say until x equals minus 12. That might not necessarily be true here, but
Stopped at the origin.
it definitely stops at the origin, yeah. Some negative x value, then stopped at the origin, remained at rest for 5 times 10 to the minus 10 seconds. We we should be able to work something a bit more about this out, like, do we know?
So is that the same thing in figure 519? We think it was moving to the right in that picture?
Yeah, I imagine.
It doesn't seem to say, but maybe it says in the chapter if I read it, but in the text for the figure 519, it just says it has been moving, but it doesn't say which way.
Yeah, I was trying to figure that part out from the book too, but I think what Suki's saying is that, like, the charge has been moving along to the right, and as far as the electric field outside is concerned, like the ghost of the charge is still moving to the right. Until it gets updated. It's like the field outside thinks the charge is still moving. So miraculously somehow I don't know how exactly that works, but the field is like, pointing at 12, and then, over time it's going to point further and further to the right until it gets updated.
Well, that's very mysterious to me.
If it had kept moving, then in our frame, it would have gone 12 centimeters over that time. So it would have been moving at 4/5 the speed of light.
What's the speed of light? You say why again?
Because the light got to 15, but the electron only got to 12. The electron ghost only got to 12.
Oh, yeah. I guess maybe they say that's like an electromagnetic wave. The wave has a radius of 15 cm. The charge, or the moving field, appears to be centered at 12 cm. Therefore, the charge was moving V equals 0.8 c meters per second.
Wow. It does say that underneath that 519. It says the field outside the sphere of radius c times t must be that which would have prevailed if the electron had kept on moving at its original speed. Isn't that weird? It's like a ghost field. Or like you said, like a ghost electron.
Yeah. Hard luck, thank you. 10 plus 3 equals 13. Nice job. But yeah, this section of the book is what I thought was like the most like mind-blowing thing that I've read in the book so far. How these electromagnetic waves are like generated. So charges starting and stopping. And so that should give us what we need to answer part B.
I think so.
So I think 5 of these 7.5 seconds were burned just staying still, but it should have been moving for 2.5 times 10 to the minus 10 seconds.
Right.
So minus 2.5 times 10 to the minus 10 seconds times its velocity was 4/5 or 0.8 the speed of light. And I guess c has meters per second built in. 0.5 times 10 to the minus 10 seconds times the speed of light. Oops, times 0.8 times the speed of light. Is that 6 centimeters? 0.059? Yeah, because you moved decimal to the right twice.
2 times 3 is 6. Yeah, that works. So it's at -6,
Yeah.
or it was at -6.
At that time, yeah.
All right.
The strength of electric field at the origin at that instant. Well,
Well, we could go back to 5.5 and use that formula, right?
Let's do it.
And theta would be 0.
Yeah.
well, did it suddenly lose all its velocity once it got to the origin? Or like, I wonder if this is inside the shell or outside the shell. I guess either way, we know it was moving.
Yeah.
I guess we don't have a way of knowing what the acceleration was, so I guess we can just use the. I think we have to assume it's 4/5 the speed of light for the velocity, because there's many different ways it could have decelerated. I think. So sorry, Finlux, which formula is that?
515, the one we've been struggling with all
Oh.
afternoon. That's the one I'm thinking of. Will it work? And then theta would be
Yeah.
0, and r would be 6 centimeters, and beta is 4/5.
Minus e over 4 pi epsilon naught. And r prime we're saying is 0.06 squared. 1 minus 4/5 squared.
9/25.
Sine squared, that becomes 0, right? Yeah.
Yeah.
Okay. So then electron in coulombs, right? Yeah, we need coulombs. Divided by 4 times pi times permittivity of free space times 0.06 meters squared. Hey, chess word. I need to close my parentheses. Times 1 minus 4/5. Oop, the 4/5 itself is squared, not the entire thing. Coulombs per meter squared electric constant? I don't think it. This doesn't feel right. Okay, I'm blaming Dr. Cook. Let me get the actual.
1/4 pi epsilon is 9. Oh wait. Where's that constant?
For some reason. Oh wait, okay. I think I have it all in Appendix K. 602 times 10 to the minus 19.
You'd think we'd all have epsilon naught burned into our brains by now.
Yeah. I'll spell out Coulomb so it doesn't think it's Celsius. I mean, I'm not going to do the units for permittivity of free space. Who am I kidding? 8.854 times 10 to the minus 12. 8.854 times 10 to the minus 12. Just to get rid of the units. 8.854 to the minus 12. Okay. Minus 1.44 times 10 to the minus 7?
I'll take it.
I have no intuition if that's good or bad, but
2.
I want to go check the answer unless anyone has any objections. Oh wait, there isn't no. Oh no. Ah,
Yeah, I thought you said there was no answer to this one.
there isn't. It's an exercise. Oh wait, Cook might have sent me the solution manual.
Yeah, he sent a bunch of stuff, didn't he?
Let me see if I can find it. Where did I save it? PurcellSolutions.pdf. Okay.
Mm.
There's no bookmarks, so I'm gonna have to do a lot of scrolling. Actually, let me just get this on the stream.
5.18.
Okay. A. Okay. 1.44 times 10 to the minus 7. Positive x direction along the
Yeah?
negative x axis towards the origin. Yeah, I was surprised too. You got the right answer. I'm reading the rest of it now, but
Wow. Nice work.
oh, nice. We look at x equals 12 because that's where the external field lines point. So it's 12 over 15c, which is 0.8c.
Yep. Ooh, 100%.
Nice. You did it.
Hooray.
Okay. Awesome.
Well, kudos, guys.
Yeah. So I was always thinking that next week we could start on chapter 6, but is that too soon for you all, or we can do this for another week, or I don't mind either.
I'm easy. No preference.
Okay.
What is chapter 6 anyway?
Magnetism. I'm like halfway through or something.
Yeah, I want to see a few more questions. I haven't looked at the problems yet, but
We can do a few more for chapter 5, yeah. Or we can do another week of like chapter 5.
I think I'd like that.
Yeah, sure. These problems are pretty fun, even if they're hard, so I definitely don't mind. Okay.
Also, chapter 6 looks long.
It is, yeah.
Might be good to have more than a week for it.
Yeah, it's pretty heavy, at least on like the curl and vector calculus stuff. But okay, so yeah, one week in chapter 5, and then we'll start on chapter 6 the week after.
Sounds good.
All right, well, thank you both for coming out to another group.
Yeah, thanks for hosting.
Yeah, thanks for putting it on. Always good.
Awesome. Well, see y'all later.
Yep. See you next time.
Mm-hmm. Okay. We want to kind of switch things over. Okay, so sorry, it's always a little bit hard to have a conversation with chat while this happens. So, Headwound, if you or anyone else who followed in are still around, this is a reading group I've been doing on Saturdays, going through this E&M book. It's been a ton of fun. It's the first time I studied. I never studied physics this intensely ever, but I also haven't taken a physics class in general in like 6 years or something at least, maybe even more. The normal theme of the stream is I answer like math homework questions. And I'm not the only one who does that. And sorry, I'm like updating my stream info right now at the same time. The people in this list all do math help in some form. So if that's something that interests anyone, then I encourage you to check out really that entire list of people, but they all have their own like styles. I want this. So we're just switching back into like a normal kind of math mode for a little bit, and then I'll wrap things up. I also normally have a whiteboard, but last couple times it's been a little bit too easy to actually set it up. Ooh, let me, before I forget, I need to export this Excalibur we just did. Yeah, critical. I'm about to switch now. So anyone has math questions for you to let me know. All right, so I'm just using Paint again today because I set up my whiteboard again. Why would you be what? Oh, that's the wrong scene. That one. that one makes more sense, Wes. Like, why am I massive? Why am I massive in that scene? It doesn't matter. All right, so critical, what are your questions? I'm going to say, like, ask the most important one first, or the most important ones first. I mean, how many do you have, dude? Because like, I don't want to. 4? Okay. I guess just start with the fast ones then. But like I was saying, like you need to rely on more people than just me, dude. I think people can do it. I maybe not giving them all the information, but like the stuff that you're asking about is critical. I'm sorry, but I don't believe that, and I also like I don't want to be hounded like to get questions answered. Dr. L, order of magnitude, how much money you'll need for the rest of your life, assuming 2.5% inflation. Is there a formula for that? I mean, doesn't this depend on how much salary you want? The order of magnitude of how much money you will need for the rest of your life. Well, there's no way. Okay, it's a Dr. L question. I don't think you need 69 orders of magnitude of money. It would be nice. Or maybe that's a real question because there's no way that's 69. Maybe it's 6.9. But no, 6.9 is an order of magnitude. I was assuming this was a meme question, but maybe not. Spending as a starting point. Maybe just like retirement calculator. Current age, 27. Oh, no, I don't want to... Oh, wait, yeah, I don't have to make it this complicated. It's, Oh, but factoring in inflation is annoying. I don't know how you do factor in inflation. What if I'm 27 and I plan to retire at 28? I'm going to be super successful. You did it with a Python script? Oh, yeah. I wish I made $35,000 a year right now. I don't want to enter in like the information like this though. If I just my current income in retirement, if I want to have say $4,000 a month, that's like what I want to do. $4,000 a month is $48,000 a year. I don't want to put that 10%. I'm going to say 0. I think I'll need 100%. No, this is stupid. Yeah, this isn't going to work with this calculator. I want to like write a script for that, I guess, Dr. L. 5,000? Let me just look at criticals questions. Impose on and retray again. I'm not writing that program for that. I'm not writing this for you. If you want, you can post code and I'll look at it, but that one's too big for me to just do it for you. Try to look at this one that we were working on the last time. Dr. L is asking what order of magnitude. Actually, the order of magnitude should just be 6, right? Like, I shouldn't need more than $10 million. That's probably an easier question than I'm making it. Well, I mean, for the rest of my life, that might. I mean, if I were to retire literally right now, maybe I would need 7. Dr. Ellis, what order of magnitude of money do you need for the rest of your life, assuming 2.5% inflation? And I was assuming it was a mean question where the answer is 69, but I realize that 69 probably isn't the answer there. So critical euro, this with scanner. I think that's $1,000 a month and being 47. I calculated the lifetime I will spend about 1.9 million during the time or 65 to 90. Yeah, I really, yeah. I got an extra 20 years. Also, having to like place a bet on how long you're going to live is kind of uncomfortable. It's like, what if you live to like 91? Just screwed then, or it's probably going to be up to 7 orders of magnitude. I mean, I feel comfortable with that as long as we're giving out tens of millions of dollars. Back of the envelope. Oh, okay. Yeah. It's an interesting thought, Brian. Originally creates a new runtime exception class. Control temperature reach assigned as a variable thermal shutdown. Gonna be Teasel's math skills and the stock market before you hit your 40s like me. Oh yeah, Dr. L. I mean, right now I'm not because I'm unemployed, but when I did my office job, I was putting a good chunk into the version of the 401k that they had, and that place also had a pension that I want to like roll over into an IRA. Is this the error message that's missing a new line at the end of the file? You shouldn't have to need one, but the code that you wrote looks fine. So if this is saying to put a new line, then try just hitting enter to put a new line and then submitting it, because I don't see what else is wrong with this. What is it saying that's wrong? Oh, that's stupid. It's because the variable thermal shutdown you're supposed to somehow know was already declared, so just get rid of this. And it should work. Yeah, I think I did one at like Vanguard's Target Retirement Fund, which I think is a little bit of a higher fee, but you don't have to think about balancing it. So critical, I knew that because of I just all took there was reading the error message. So I'm very certain if you showed someone the code in the error message that they could have answered that too. Apparently I did, but like, did you give them this exact screen? Like these, if you gave them these two screenshots, I would be shocked if no one could do that. Like just the first screenshot, yeah, I don't think people can do that because the way you have to do these assignments is kind of stupid. But if you gave them the error message too, okay, well, I guess even if they can't, like, I'm not always available. Like, you're gonna need to figure out some other way to get help too. Hey Pearl, what is minus 381 times 6 to the power of 5? A math problem for a calculator. I don't know, so there's a little bit of ambiguity here, but if it's like the number negative 381 and then separately times 6 to the power of 5. Oh, why is Wolfram Alpha doing this? I hate it when it doesn't tell you the actual number. Oh my god. Why? A stupid website sometimes. I'm sure that Desmos will do this, right? Minus 381 times 6 to the 5. It's... So there's two different interpretations of it, where one is that interpretation, the other is this interpretation. Pearl, so I don't know which one you mean. But if there's no parentheses, then it's negative 296,000 or negative 2,962,656. And if they're both in parentheses, oops, I did that. The power, no, it's the power of 5. If it's if they're in parentheses, then it's this. The first one? Okay, yeah, then there's your answer. Four 20 to the power of 69. Why would overmail not give me the actual like number? I don't get why it would do that. Yeah, I was hoping there'd be some kind of funny number hidden in there. Oh well. Oh, there's a technique for those questions, Firefox. I forget the trick. It's either the bigger base wins or the bigger exponent wins. I think the bigger base wins. So 420 to the 69. I forget. I know there's a rule for it. Six 69. Really? Maybe the higher exponent wins. Oh, this one's getting... Okay, well... Undefined is quite a bit bigger than the defined number, I think. I assume. Huh. I swear there's a rule for it. Oh, wait. It's for A to the B, compared with B to the A. Oh, wait, no, but that is the same situation. So maybe the higher exponent just wins. There's a black pen, red pen video on comparing A to the B with B to the A. Busted floating point precision, yeah. You need a second line of code here, critical. You need to do, like... They give you an int size that you have to assign something to. So size is going to equal file dot something that I don't know. Like they need to... There should be a function somewhere for the size of the file in bytes. I don't know. Just Google Java file. Oh my god. So you literally just Google Java to look up the, or, you know, Java file object to bring in the documentation, and then look through the list until you find one that gives you what you want. I'm gonna see if there's just like dot size. Nope. There might be get size. Nope. Wait, length? I'm not scrolling on Twitch the whole fucking day. Yeah. Length worked? Okay. I said when she married me. Yeah. I mean, I hope for a little more enthusiasm than length worked, but you know, you gotta take what you can get. Java's what I first learned. Well, not first learned, but a lot of my school computer science classes use Java. Brian's got the jokes. Oh, okay, Dr. L. Thanks for hanging out. And it's not like what's the error message? Critical. Oh, I'm sorry, I wasn't showing it. Would be a better way to say that. Dr. L, thank you so much for the prime. Holy crap. I appreciate it. It's making the exact same mistake. I really don't know here. What do they tell you, or like, do they give you the file that you're scanning? Uh, is that what you just posted? Oh, I guess so. The PLN's and moving protocol kind of moving with it. Yes. They kind of have to be. It'd be weird if they weren't. If it has constant velocity at least. I don't have a environment set up to run Java. I guess so, Brian? I just don't know critical. You're back? Oh. Well, I can't compile this file. I don't have an environment set up to run Java code. And I just don't see what's wrong with this code. And in this website, you can't properly troubleshoot code. So I don't know. Like, I don't see what's wrong with it. I don't know how it's possible that we're undercounting the characters and overcounting the words. Yeah, I guess so. I don't have an idea for you, really. Uh, oh, my mouse just died. Isn't that great? Plug it in. So yeah, send another one and send the error message. Copy. It's not copying. Ugh. Oh, 1 second. Okay, well, I'm seeing a consistent thing here, critical, which is assume they've already been, or like they say to assume the variables have already been declared, so you need to get rid of these again. I don't know if there's more that's also wrong, but I mean, or unless is that code, is that part of the code given to you? Actually, we might not need the first line at all, unless like is that provided by default? Because they say the file name is already made. Like you shouldn't have to do anything with file name besides accessing it in that line. Got a math equation today. What's that hard locked? Zero plus 0 equals 64. That's a great math equation. You can prove it? How's that? So critical, I feel like I'm kind of repeating myself here, like just like the error message just says like you need a semicolon on line 5. So put a semicolon on line 5. Oh, computer guy. Thank you so much for the raid. How's your stream? Uh, 0 degrees C equals 3 dew degrees Fahrenheit. 33, 32. What is a dew degree? Post the pic in the art channel. What? Some kind of like I don't even know what how to show it. There. Like like how did you get that little like face of me? It's nice. You know. You know. Computer guy, the double raid? I wonder if there's like a tech issue happening. Either way, hello, computer guy. Oh, 32. Oh, I get it. Okay. 32 plus 32. Hey, how's your stream, computer guy? Thank you very much. I'm probably not going for it too longer myself, to be honest, but but yet, so critical for this one, like it's just put a semicolon. It says to put a semicolon, and then the other thing is that it's raising an issue with the catch and finally, and there's just no try above it. Like stream well back is a bit sore, so I'm gonna stop and stretch again. Oh, okay. Cool. Glad to hear it went well, and definitely take care of yourself there. Give me one sec. Because I don't see a closing bracket down here. Just gonna do a little bit organizing. Can I make Wolframe like actually give me a number here, like -381? It's so annoying that like why would it not say the result in an actual number? Like how can I make it know that I want the actual thing? Okay, I cannot hit enter, but that's stupid. There, I can make it equal x. Oh, the comma that's there. Oh, it's stupid. Okay, the compiler before was just bugging when it wanted the semicolon there. Get rid of that again. I thought it wanted a semicolon because there wasn't the try there, but since the try is there, the semicolon is messing it up now. Oh, equals? No? Send the message. What's the error message? Critical? Oh, I did just notice like this should be capital S. If I get $1,000, can I hire you for a week to code stuff? Me? You're not gonna get very good code. Hey, SPQ. Cannot variable line location class filled answer. Yeah, Jed. I don't know what this one means. I'm not gonna write that out though. I don't know why that one would work, but yeah, it's I don't get why Wolfram Alpha does that. I guess it has something to do with using the caret symbol. All right. Well, when you don't know the error code, you Google it. Yeah, I was checking that too. I think line is given to you. It's this weird website where they don't show you the entire code. They tell you what variables have already been declared, like in the prompt. No, it's not the right prompt. No, it is the right prompt. Ugh. Given a file's name is stored in the string file name. In the string file name, write a code snippet count number. No, that's what? Oh. Count is already initialized, or count is declared. File name is declared. So critically, you need something up here to define the stuff that they don't define for you. Like, they say count isn't initialized, so you need to say count equals 0. You need to do something with scanner. New scanner file name, I think. Oh, capital N? Yeah, capital N. Then that might work. I think that opens the file for you in Java, or you can just start reading. Oh, that's because it's next line, not read line. I'll just cross the whole thing out. Yeah, I feel like this, like every single thing that I've like found in all your coding questions come down to reading the question and reading the errors. Like I feel like I'm just kind of repeating myself over and over here. All right, because this is something that like you should be able to do too here. It's okay. I'm just saying that like you really need to learn to do this yourself. Like if I'm always just doing this for you, like you're not going to learn how to do it. Yeah, but you like me doing it for you isn't going to help you learn. Line 4 is still wrong. Parentheses expected. Well, yeah, you deleted the. You still need the other parentheses on the end. If there was no such element exception. I assume that extends at some point IO exception. Like, isn't IO exception a really? Oh, I guess just exception is everything. You took away one too many of the parentheses critical. Just put one of the parentheses back there. Inherit from runtime exception? Oh, really? Let's see if this code works, and then we can change that part after. It's not. Well, we don't know if it's going to make an error with that. Glad to hear it, computer guy. Here to study the math now? Oh god, well, unlucky because I'm working on a Java question from Critical right now. What is it telling you then? Like, what's wrong? Oh, you... This thing again? Offered a job an hour a week with the company? That's something. Congratulations. Or it's CEO soon? Hey, you know, hope for the best. Uh so got my dashing. Nice. Oh, it needs a file, not a string. Um No line there. You need something like file equals new file name. And then down here you need to make the scanner take file as its input. Because like the error code is saying that it's not finding the method that we're calling with next line in length. And it means that we're setting this up wrong. Like we're not making our objects correctly. We're gonna talk about assembly. Uh yeah, my assembly language class. Like I kind of like that I know it, but I did not enjoy learning it. My bad. I critical. I need the error. Well, I mean, I think this is just a typo. Like, you need a space in here, and that, like, you put that in all caps, but it's just capital N, lowercase the rest, and you need to update that file name down there to be just file. Those are classes that I took for computer science bachelor's, but not that one. Do you take an operating systems class? That one was like, there were some really cool things in there, but God, there was so like, it was half cool, half the most tedious thing I've ever done. Very basic for commerce school. Oh, okay. Take a stretch break. I'll stretch when I want to stretch. Oh, you have a cat? Aw. Don't tell me how to live my life. Stop licking your butt. Ugh. Yeah, cats are just shameless about that. Just stick their leg right up in the air and go at it. Hmm. I don't see what's wrong with this. Uh, I think I'm just done. I mean, the cat looks like that they're stretching out when they do that. Line is still not declared? Is it? Oh, I forgot about, yeah, you did say that, SPQ. Okay, well, insert a string line right above the loop, because you do need to declare line. Yeah, you need to tell Java what data type line is. You can't just start using line. But yeah, past that. Okay. Um, I still don't know. When it comes to these Java questions, either I like I realize it's not easy when you first start. Like I also had a hard time with it when I started it, but like just going through the struggle of trying to figure this stuff out is what made me learn. So I'm kind of done with answering the other types of questions where it's like it's more or less just like looking at the error and chasing that down. But this one is still like looking at the error and chasing it down, but it's a little bit more complicated than just like a missing semicolon or something. It did work? Okay. Yeah, like just like going down the line and if I'm making the same fixes over and over again, the last one didn't go through. What does this mean? Resource cleanup. They might want you to do. They might want you to close the file after you're done with it. You would close the scanner, I think. Reader.close. Maybe. Actually, that should really go in the finally block, shouldn't it? Because you want to close the file no matter what, once you're done with it. It might mean something else, but it's my guess. Reader.close like down here isn't working. Maybe try putting it up where I thought it initially would go. Okay, it seems better to put in the finally block, but that's how they want it. That's how they want it. I'm gonna wrap it up here for the day. When it comes to those coding questions, critical, I'm kind of done in general. Like it's just too many questions that come down to, you know, reading the original question or reading the error message or just schooling what the class does. Like the exact same thing that I've been doing. Like it's not hard for anyone else to do. So even if you're not sure, like there should be like there are a couple of hard ones in there to diagnose, but like those easier ones anyone definitely could have done. Um Okay, I'm gonna cut the YouTube stream off here. So if you're on YouTube, I appreciate you.